Hello, everybody. So today we're going to continue with our structural class. We've already framed our basement or first floor. We even have a second floor. We do have a subfloor, which we're not showing right here. Technically, the bottom plate's sitting right on that. But we're not going to be modeling much of this right now. We're going to be going back to our structural software to talk about different types of materials that you need to be very familiar with when you're working on these projects. You need to understand the differences between one and the other. And to do so, I have my good friend Google right here, and I have our structural software right here. So as you guys know, the structural software generally is organized in such a way that you start with foundations and footings on the left, uniformly loaded floor beams, roof beams, the full framing combination, which we don't use this as often. We should probably use it, but we don't use it as often. I haven't really used it much. And then we have the multi-loaded multi-span beam. We have the multi-span floor beam, which is not a multi-loaded multi-span. It's just multi-span. We have our multi-span roof beams, combination of members. Or good friends that we use all the time are the foundations, uniformly loaded, multi-loaded, multi-span. We use our floor joists or roof rafters, columns, and we use our collar ties a lot, and sometimes we do walls. We don't use much of the hip valley and hip and valley beams, which should also do that too, but we don't use it as often. Okay, so that's it. Let's talk about what the beams could actually be made out of. Okay, so we select beam. We know that it asks for, how it's going to be loaded, how long the beam's going to be, the width of the beam, the span of the beam, what the tributary width is, and what, in one side or the other. And if it has any wall point loads or supporting any wall loads, you can actually put the wall load pounds per linear foot, PLF, right here. And you can put right here any point loads that should be sitting on it, if anything is sitting right on it. But on the left, our structural software tells us there are 1, 2, 3, 4, 5 different types of ways of making these beams. Solid sawn. A solid sawn piece of wood, as it's called, is actually a piece of wood that gets cut right from the tree, dried in a kiln, in a dryer. It's like they either dry it, they actually literally put it inside a heat area where it evaporates. It's never really fully evaporated. The full content of water that moisture that the wood has never really just goes away. It stays, a good portion of it stays there. All right. But this is solid sawn. Solid sawn members come in different sizes. And we'll talk about that in a second. But they are literally made out of wood. So there's different types of wood. Depending on the location or the area where you're at, you will use one of these guys right here. We typically just use the default Douglas fir latch because it's a very typical wood that's used in places like Home Depot, and you can get it very easily. So if you want, to buy a 2x4, and I'm getting into the sizes, but if you buy a 2x4 member, likely is gonna be made out of some sort of Douglas fir material. Okay, so you open one of these ones, and you go into the specs of it. Let's see if we can find it. Specifications. It will tell you this is a spruce. So you could actually, that's a typical also, another one. So you could actually find spruce right here, all the way to the S, right? Spruce. And each wood, just like we're all not created equal, actually, we're all different people. Although we're created the same. But the wood is not all created equal. Sadly, they're not created equal. So each species of wood behaves differently depending on the conditions, right? Like the way it's built, the way it's grown, the way it grows. Each material is different. So we use a lot of Douglas fir because it's very popular. But in this case, this one is a spruce. So this So the first tab is what kind of material we're going to use. And we're focusing on solid sun right now. So for good practices, for really good practices, you're going to use solid sun for general floor framing, traditional conventional framing, nothing too elaborate. Spans are not too long. So for floor framings, you're going to be using, solid sun generally, likely 2x8s, 2x10s, 2x12s. You would not go any smaller than those for typical floor framing. For wall framings, you're typically going to be using 2x6s or a combination of two 2x4s. We'll talk about that two 2x4s condition later, but it's an interesting one. You barely ever would use 2x8s for wall framings or 2x10s for wall framings. That's not typical. That's not something you would typically do when you're framing an exterior wall. For interior walls, however, you do use 2x4s. 2x4s is typically the standard framing wall for an interior wall on a single family and two family residential kind of a project. Now, keep in mind, and this is a disclaimer for everybody, your project, the project that you're working on may differ from what we're doing right now. So don't take everything I'm saying as a law, just you got to do your own due diligence. I'm talking here about particular projects that we generally do here for design architects, and it's not to a particular project that you're working on, whatever you're at. So that's it. And this is actually for Flow Design Architects members. So, hopefully you understand what I'm talking about. So this is the type of wood. So it's just the type of member is generally going to be solid sawn, and these are the type of species of that member. In this case, this is made out of spruce. If we go into 2x6, likely if you write Douglas, you will find that there's Douglas fir members, which are pretty good. And just so you know, we're gonna go to the specs real quick down here, specifications, product details. So this one right here. So look at the specification. Remember how I said it's dried on a kiln? If you don't know what a kiln is like an oven, okay? It's like a place where they dry this. Of course, that's not, wood. That's not the one. But they dry it on a kiln, which is like a furnace, like an area that's hot right here. And that's how they dry it all. They get all the moisture out by drying it on a kiln. Okay, that's what's called. It's like a big oven. Just imagine that as a big oven. Okay, that's how they do it. And they dry all of the wood to get all the moisture out of the wood. Okay, so if you go to Home Depot, it tells you really good information about this. It's dried on a kiln. It's dimensional lumber. Explains how they're made. Specifications right here. It's the sizes that they're made. This is, by the way, you see how it says spruce / pine / fir. They're similar types of wood. They're similar species of wood, okay? So spruce is actually a type of pine, okay? So if you go to spruce, it's basically a pine. By the way, there's generally two types of trees, coniferous trees and deciduous trees. And I guess, I'm getting into more beyond structural, but coniferous trees basically generate cones. They create cones. So all of those trees that create cones are called coniferous. They are green. They're also called evergreen. They're green throughout the entire year, all year long. So now we are here in fall right now, November, right? And all of the trees that lose the leaves are not coniferous. All right. So that gives you the answers to the other ones. So conifers are really good for all year round shading and protection from wind and things like that, because they will stay there all year round. Okay. So that's good. That's coniferous. But then the other ones are called deciduous trees. Deciduous trees. Deciduous are really good for shading during the summer. They do lose their leaves during the fall. Okay, so they're really good. I would, that's a design topic, and I don't want to get into design right now, but they're really good for shading during the summer where the heat's really strong and we don't want a whole lot of heat. And they're very good to let the light right in during the winter and the heat during the winter when we need it the most. in places where we have 4 seasons. Okay, it's not the case for the Dominican Republic because all trees in the Dominican Republic or places in the Caribbean are basically green all year round, right? They never really lose their leaves. So that's that. That's what we're talking about. So we're talking specific to North America, and the East Coast. Okay, so northern East Coast. So northeast. So that's it. These, you see how it says like, spruce, pine, blah, blah, blah. They're all parts of the same family. Like if you write Douglas fir as a tree, it's another type of pine. They're all types of the same family, generally families of each other. Okay. So there's a coniferous type of tree. So all of these guys generally that you see here are all going to generally be a type of pine. Why? They're abundant, they're easy to plant, there are a lot of them, they're very strong and dimensionally stable. They're very good for this use. So they're very good for this use, okay? So that's the case for that. Any other type of wood will be used mostly for finish, like cabinets, flooring, doors, things like that. Although we do use spruce and pine for doors too. They're fine. Okay. And then there's different types of families of woods, the hardwoods and the softwoods. Most of the softwoods are actually these ones. These ones are softwoods, the Douglas fir, the pines, they're softwoods. The hardwoods are things like walnut, all of those, very robust materials. So those are that. So I don't want to get into the details of that, but this is the difference. So you can use either spruce in this case or Douglas fir. I want you to always refer to the default Douglas fir. I think it's a good one. Now, types of materials, type of species of the material, grade of the material. All right, let's memorize this. Type of material, type of species of a material, grade of the material. Grade refers to the quality of the material itself. Okay, so as you guys know, when you cut a tree, not all of the pieces of that tree are going to be premium, great quality. Some pieces are naughty, like naughty wood. Let's just find a naughty wood. But, some pieces are very naughty and not of high quality. And this doesn't help it. It's very bad. It can crack and break. It's not good, right? This is not a good one, right? So they go through a process of actually putting piles of different grades of wood. It's more elaborate than these, obviously. I'm generally teaching you a structural class, I'm not teaching you how to pick wood kind of class, all right? That's not what I teach. So, but they put the general horrible pile, the medium pile, the premium pile. And that generates this right here. Utility type of wood, not used for anything really good at all, right? Stud. This is good for walls, actually. Studs, they're really good for walls, generally, no problem. Standard, also pretty close to the stud. Then you get into this grade. Select structural is le creme de la creme. That's the best. Okay, so that's the best. So these are the different types. You can ask ChatGPT to tell you with more detail what each one of them is, but I'll tell you, we typically use select structural for almost everything we do. Unfortunately, that's not the best way to go about it, but it's the safest way because it will be the most quality one out of all of them for solid sawn. They come in different sizes. So the structural software here talks about layers of them, how many of them. It talks about the thickness of the material, and it talks about the depth of the material. Okay, so layers, how many of them, thickness, depth. Right. So if we go to our nice little Revit model, this is one member that's going to be 1.5 by the depth of this material, which is, in this case, I believe is a 2x10. But if we happen to have two of them ganged up together, that is called sistered. That's called sistered. If anybody asks me, if anybody wonders, what is it called when you put 3 of them together instead of 2? Well, there's no term for that. I don't think there is. If you want to call it brothering, then good, but don't put it on the drawings because people are going to laugh at you. So it's not brothering, it's sistering It's only when you do two. There's only a term for that. There's not that. Okay, so this thing right here is 3 layers right here, right? So that will have 3 layers, and this is an LVL type of material right here. So this right here is the amount of them that you're gonna have together. For regular floor framing, you don't typically have too many together. You do that in certain aspects where you want a bigger span, or you're gonna have a floor above that's gonna have a bathroom or a kitchen. It's gonna be very, very well loaded, and they're gonna cut through it. You want to make sure that when they cut through it, they do it properly. So you want to sister them. I'm not typical. All right. So when you click on the flat use, is something that you may not quite understand. So right here on the flat, so just, I don't want to get too far. So amount of layers, how many of them, thickness of the material, and the depth of the material. We typically use 2x4s, 2x6, 2x8s, 2x10s, 2x12s. That's as far as we go. We don't go any higher than that. These are readily available at any store, and we don't want to go into custom territory. Custom is pieces of wood that they had to make for your particular job or a special order. Special order, consider special order like significant price. Significant. It's more expensive, so you don't want to do that. So that's that. So, are we clear on that, everybody? You can comment on the comments below, on the meeting notes, on the chat. If you have any questions, you can type them right there, and I will be very happy to answer those questions on the chat if you don't mind. Okay. So if no questions, I'll continue. So that's it. So these are the differences. So the on the flat use is something very interesting that most people don't know, and it's the fact that and typically it's used on walls. On walls, you will use it on the flat. So when will you have it on the flat? So you know what? I'm gonna just have some fun here. So this member right here, this wood right here, this stud, right? This is a stud. You could actually frame your wall for a basement that you may want to finish, and you may just literally begin having a bunch of these members like that throughout. Okay? Right? And you're building your wall right there. And then you're going to put your sheetrock right attached to it. I mean, ideally, you're going to put your insulation like that, and that's great. No problem. Nothing wrong with that. That's cool. You get a lot of insulation in there. That's completely fine. That's completely fine. No issue with that. Okay? But, you know what? I'm going to bring it all the way over here. And we're going to talk more about how we can frame those guys later. But you could use it on the flat when you don't want to lose a whole lot of square footage on your basement. You're like, oh my gosh, I don't want to lose a whole lot of square footage. It's very tight, blah, blah, blah. So you know what? I'm going to do 90 degrees. Well, not like that. It will be 90 degrees like that. So, and I'm going to do it on the flat. And yeah, you can do that. You can literally put your members on the flat. That's what's called on the flat. You now see why it would be very silly to try to do a roof rafter, a floor joist or a roof rafter on the flat. Doesn't make any sense to do that. I mean, it's not structural strong. I cannot think right now of a particular reason why it would be a good idea to frame your floor like that. That's just not cool. Unless you want to use them as subfloor, which is not something that we do. Okay, so that's that. All right. So I hope that helps understand that part right here. Okay, so we're good. So that's beautiful. So that's it. This is on the flat. We don't typically do that because when you're finishing a basement, you have to get some really interesting R values, and it's very difficult to get the R value if you do them on the flat. By the way, on the flat would actually not be floating. It will literally be right onto your foundation wall. Okay, so that's it. You don't get a whole lot of insulation in there, right? It's 1.5 inches. That's nothing, nearly nothing. So you use that on that case, but you can use it in other case scenarios. I can think of other case scenarios. Like if you have a chimney and you want to cover up that chimney, you may fur that out. That's called furring. When you fur that out, furring, let's just word the word furring so you guys can see it. So you can fur that furring around chimney. Well, like it fills it up right there, right? So because you want to cover that up and you don't want to take a whole lot of space, you just furrow it out with some furring. That's the material. That's what it's called. Now, that's on the flat use. You don't do that. You typically don't do that for most applications. Not common. So that's on the flat use. Dry right here or wet is like I cannot think of a reason why you would use wood that's wet. It's certainly cheaper. Literally, you just cut it out of the tree. You didn't dry it on the kiln. You didn't dry it. But I cannot think of a reason why you want it wet. Okay? There are a lot of problems with using wet wood. One of them is it's inflated, it's thickened, it's fat, it's big. And when it dries over time, it will thinner. It will become thinner. So if you build a house on a piece of wood that, or multiple pieces of wood that over time begin to shrink, which is going to do anyways, just so you know, it's not dimensionally perfect. You will be sued all day long, every day. You're going to have issues with that. Okay. So this option is right here. I don't know why they would want to do that. I cannot think. You know what? I'll open my friend ChatGPT and I'll ask any reason why you would specify wood for framing that is not dry. I don't think that there is any reason, to be honest, right? Specifying wood that isn't fully dry for framing is generally not recommended because of the potential issue it can cause. Here's some reason. Shrinkage and warping, we already talked about that. Dimensional stability, structural integrity, not good. Mold is going to grow out of it. Construction time is going to be a problem. Difficult to finish is going to be a problem. I mean, there's just no reason why you want to do that. And you're like, why does the software have it? Well, because I didn't make the software. That's really it. Someone that wasn't thinking probably made that particular tool. Another tool that you don't know about, and a lot of people don't know about, is something called flitched plate. Flitched plate. So it's not used a lot. So let's show you flitched plate. But it's a combination plate of wood and steel. You can make a sandwich out of your structural member and put steel inside it. It will make it stronger, way stronger than if you didn't have it. It's an option also, believe it or not, for when we're doing our typical open concept projects where we have a kitchen and we want the member to not be too deep. You can use a flitched plate. But here's the problem. Oftentimes, our contractors are a bit lazy and they don't want to call any other trade because it will take a lot of time to get the other trade that's going to cut the steel and make the steel. They don't have tools to be cutting steel. They have wood tools for wood, but they don't have a whole lot of tools to cut steel, right? And they don't want to get into that. They really don't. But you could do flitch plate, and that opens up another option for how many pieces of plates you're going to use and how thick they are. And it makes it stronger. It does. It is a tool not used often here at Flow Design Architects. We don't often specify. But most of the time we don't use it because most people at Flow Design Architects do not even know it exists. Okay? And I'll tell you what, I will forgive them. I didn't even know it exists. Because our architecture school, we don't get taught those things, right? We learn it on the go. We learn it as we work. So we learned that. Pretty cool member, pretty interesting stuff, pretty cool stuff. Okay, so that's pretty straightforward. You can make how many members you want, how thick you want them. This is the thickness of the actual member, the thickness of the actual flitch plate, and that's that tool. Okay, so you have all the tools in here which we don't mess with often. You can call this a deck beam or a floor beam. So a deck beam is exposed to the outside. A floor beam is in the inside. So when you're doing a deck outside, you don't necessarily have to do a floor beam. You can change it for a deck beam, okay? It will change some information about it, instrumental information about it, regarding the insisting factor and some other factors and so forth and so on. So also, if you change it for a deck beam, you could actually apply snow loads and things like that because it will be outside. And if you live in a snow place, you may actually have to add that in there. So that's that. All right. So I wouldn't get too much into it. I wouldn't mess too much with that. So these are the different members. Talking about sizes, I mentioned to you, and you saw it right here. There is nominal name, and dimensional. Dimensional is the actual dimensional. Nominal is name of it. That sometimes people have a hard time understanding that. And let me see if one of these books, likely one of these books, can explain it a little bit better than me. If they do decide to open up today, things are a little bit slow today. You guys know it's election day too. Things are not as cool. Nominal. Okay. So let's just find nominal versus dimensional wood. I think there must be an explanation, a really nice explanation for nominal wood versus dimensional. If it decides to open up. I mean, I'm sure this thing is gonna show it. I really don't understand why my computer is so slow today. Maybe just upset, because today is election day. I don't know. Maybe the computer is very upset. I don't know. So that's that. But we can go back here and say, well, nominal wood versus actual wood sizes. So dimensional is the actual wood size. Nominal is how it is. So this is a good one. I like it. You know what? I'll take it. This is a good one. What is it? So I do not want anyone ever putting 1 inch by 1 inch. That's not true. That's a lie. That's incorrect. 1 by 1, it's not 1 inch by 1 inch. It's actually 3/4 of an inch by 3/4 of an inch. Okay? 1 by 2, it's not 1 inch by 2 inch. So I do not want to see ever anyone calling it 1 inch by 2 inches.
No.
Okay, so I hope you guys get that. So this is the name of them, but you don't put the inches in it. Okay, you don't put inches in it. As you guys know, wood gets caught in a very nice tool that cuts all the trees and makes all these lumber pieces, and they cut them exactly to be 2 inches by 8 inches. When you put it inside a kiln and you dry it, guess what? You lose a little bit out of each member. And that is the difference between the name, a 2x2, a 2x4, a 2x6, a 2x8, and the actual size. I like always talking in terms of the actual size. You guys are always gonna see me saying, when it comes to LVLs, I really like talking about the actual size, because when they're talking about different things, right? A 2x8, there's no such thing as a 2x8 LVL. That doesn't exist. So if somebody says, oh, you know what, I'm going to buy 3 2x10s LVLs, like, do you mean 1.25 by 9.5 by 9.25? What do you mean? Because they're not that. They don't exist. We want to be proper with our speech. We want to be very proper with our speech. It really creates a cementation. Like, you can engrave the knowledge in your head. So when you're doing these models 3D, which you wouldn't need to do much, you would immediately be able to know, that's 9.25, right? I'm gonna need my strap. I'm gonna need this. I'm gonna need that. And you can quantify these things, and you can make your building like if you were building it with your hands, you would know how to do it by using the proper terms. So these are the proper sizes of each one of those members. That's exactly the size of each one of those members. Okay. So that's it. That's that. These are the grade. You can have them round. I would never use that. I don't see why you would want to have a round member structurally for these things. I don't see it. I don't see why. So that's that. Okay. If you change, you can go to glulams. And let's go to the glulam world. Glulam. What are glulam? Glulam are a sandwich of a bunch of dimensional lumber tied together. Literally, they tie them all together. But these are dimensional lumber. These are 2x that they glue together, and they're very strong. And you would say, well, what makes it strong? What doesn't kill you make you strong. But no, that's a joke. So what makes it strong is the fact that they glue each one of the grains against each other in a different manner. So you see how the grains here are facing up and the grains here are facing down and the grain here are different. That makes it strong because the wood wants to warp in different directions. So that makes it very strong. But also the way that they glue them together, it makes it strong, right? We are stronger together, right? So that's a good one. There you go. So it's stronger together. All the members are stronger than the individual pieces. So that's glulam. We barely ever use glulam here at Flow Design Architects. We don't use them. We don't use them often. And you will say, why don't we use them often? Because they're hard to find on like a Home Depot. You can just, you can write LBL, you find LBLs right away. LBL beams. Good. Here you go. Ready to go. LBLs. Gone. But glulams, they're not that typical. They're not that typical. Most of the time, they're not that typical. Okay? So they're not that typical. So I would either use LVLs, which is actually structural composites. That's actually an LBL is part of a family of structural composites. So, or I would use a glulam. I wouldn't cross each one of them on a project. People would not like you for that. Really, doesn't make any sense. It's like having white windows and green and black windows in a building. Like, why would you do that, right? So you wouldn't do that. So that's the glulams, and the glulams have, again, so that's the type of material generally, right? The class, and this is the different species, right? If you will, right? Like the different species of the material, and this is the different grades of the material. All right. So I hope this is good. I hope you guys get that there is, a category of a material, a species of a material, and a grade of a material. All right. A category: wood, steel, solid wood, LBLs, structural composite, glulams, right? So they're different, right? Glulams, just so you know, too, are typically horizontal members that make up a vertical member altogether. You see, these are a bunch of horizontal on the flat, if you will, on the flat, that make up a vertical beam type of material. They're very dimensionally stable. If anybody is taking the ARE exams, this is a question actually that you may get. I don't know, but they are very dimensionally stable because of the way that they are, the way that they're dried, and the way that they're glued together, and the way that they're put together. They create this cup right here, and then this other area that makes it very stable because they push against each other. And by pushing against each other, they cancel each other out. It's like, I push you one this direction and you push me one this direction. We moved zero, right? You guys get that concept? Thumbs up if anybody got it. All right, excellent. So that's that. So those are those members right there. And I don't use them. So I don't want to go into details. I don't use them often. I don't care much about them. If it comes to the time that they become more popular than structural composites, and we'll probably go about them. Most of our contractors don't use them, so we don't want to use them. But they are a thing. So if you are looking for alternatives, you could do that. And you will say, "Wow, Darwin, all of these open concept kitchens that I've been trying to do, that I could have done using glulams that probably will be stronger. Why didn't you tell me about that?" Because they won't try to get them. They're not going to try to find them. And it's going to be a mistake. They're going to get LBLs instead of glulams, and it's going to be a confusion. So, we'll talk more about that later. The comparison of strength. They are typically stronger than any other wood member. LBL, solid stone, they're typically stronger. So I'll do an experiment with you. So I'm going to say that this member is going to be 14 feet long. Okay, and that's gonna span. It's gonna have a tributary area of 7 feet in one side and 7 feet on the other side. Okay, and we're gonna put 3 of them, and I'm gonna say, you know what? I'm gonna put, and they have sizes that you would never imagine because of the way they're made. They can make different sizes of this thing. Right? So they have more options on sizes. To be honest, as you can see, they go as deep as 44 inches. That's really crazy. So that's that. All right. The more I'm talking about it, the more I think it's a compelling argument. There's a compelling argument for why we should use it sometimes, to be honest. So that's it. You know what? We'll go and say, you know what? We'll use the 8 1/4 one. Okay. So 3 of them. This is the grade. We'll use, I don't know, we'll use one of the high grades. So three of them stacked together. 1, 2, and 3 of them stacked together. 3 inches each. That's really crazy. That's really crazy. Yeah, I wouldn't want to use 3. I'm gonna use 2 because that's gonna make it 6 inches. Okay. So that's good. So that's gonna make 6 inches in width and 8.25 in depth. Okay, and there are 3 of them together. I mean, 2 of them together. So we go here and say, okay, let's go. That fails miserably. So let's try to do 3 of them. 3 of them. Let's do 3. Okay, that still fails miserably, but I want to use a passing example. Okay, let's use 4. So 4 members, 4 of them, 3 inches by 8.25 pass by 13.7%. So if we were to, so that's 13%. If we were to go to structural composite and find a similar member that will be the 7.25, it's actually not even 8 inches, and find 4 of them at the highest stress class, they fail by 122%. Okay? Now, and that was 4 of them. So we do 3, and we say 3.5 each, still fails by 48.1%. Even though you may get the same amount of members, and my example is not a 1-to-1, you got to study it a little bit. I think I was doing something wrong. So if I was you, I would check it a little bit better. But the point that I'm trying to make is that the glulams are a lot stronger than LVLs. But the LVLs are way stronger than a solid sand. So we're going from the little baby to a little bit bigger to the biggest. We just happen to skip the glulams and typically move all the way to steel. We're like, you know what? We're not going to do that one. We immediately go to steel as an option. But you do have the glulam as an option, okay? So I'm glad you're aware of this. I'm glad you're understanding it. I'm glad you're seeing that they're way stronger than any other member. But I want you to study these a little bit more and understanding a little bit more. They have different grades. I mean, different families, different grades, and so forth and so on. Okay, so they have a lot more options, way more options. In fact, you could actually ask ChatGPT, what is better, a glulam or an LBL? I don't know. Let's see what ChatGPT says about that. Both glulam, glue laminated timber, and LBL, laminated veneer lumber, are engineered wood products. That's true. There are similar structural purposes, but they differ that they make preferable in certain scenarios. Glulams made from layers of dimensional lumber, regular lumber, glued together, are typically stronger than LBLs. Okay? Glulams look way better. I mean, you can see it right now. They're beautiful. You can make these beautiful trusses out of them. You can make really beautiful things. They're more expensive. That's another reason. That's another reason that why we don't go all the way up there. Okay, so that's that. You can make really interesting things. Okay, now this is not a class on how to use ChatGPT, so I'm not going to be talking about that. But glulams are way more dimensionally stable. They do cost more money. They are more fire resistant because they're a lot thicker, solid. They're more resistant to the environment. I mean, there's a lot of reasons why you would use glulam versus using an LVL. But sadly, our contractors are generally not using those. So we're not going to fight that. All right. So that's that. And then we go to structural composite. An LVL is a species, if you will, of a structural composite. It happens to be the one we use most. That and the eye-level truss. Okay? That and the eye-level truss are the ones that we use. So eye-level trusses are kind of like TJIs. Eye-level truss. Photo. All right? So we call those guys TJIs. TJI is actually a family of those guys. So don't get too confused. TJIs are a type of a family. It's an eye-level truss type of family. There are multiple options of those. Those are typically used for floor joists and roof rafters for long spans, very long spans. Okay, you use them for long spans, that regular 2x10s and 2x8s and 2x12s will not take care of for you, okay? So that's when you go there. They're way more expensive than a regular 2x12s. They are, but they're worth every penny. They're certainly worth every single penny, okay? So that's it. That's that. So those are different types of them, okay? So they're different structural composites. These are different brands and groups of structural composites. Like I said, I only go to either the LVL or the eye-level truss. I don't go too far. When I go to the glulam, sometimes I do try to find my, yeah, that's it. There is another one called TJIs. They're not here for some reason. I can't find them right now. But likely because TJIs are not used for beams and the software takes it up. By the way, you shouldn't be using eye-level trusses as a beam. I don't think it's the best way to go about it. I mean, this thing shouldn't be a beam. Okay, generally it shouldn't be a beam. I have never really seen it as a beam. So people will laugh at you if you were to use that as a beam. So, but that's why they don't show up here. But if you go to floor joists, let's go to floor joists. You're gonna find eye joists. And those guys are the guys that we call TJIs. Okay? Those guys are the guys we call TJIs. So right here, these are different grades of the TJIs. That's a group of them too. TJIs, eye-level truss. These are options that show up here because they are meant to be used for floor joists. So TJI. By the way, these are different brands of it. Okay? Eye joist, TJI. They're all brands of them. They're different brands of them. We always just settle for TJIs when we're working with this stuff. The eye-level truss, TJIs. So those are the ones that we typically settle for. We don't go any further with that. But those are only for floor joists. Floor joists. Let's just engrave that real quick. You use them for these guys right here. You do not use them for these, for beams. Okay? You don't use them for that. Okay? So, and since I was on the beam category early on, floor beam right here, that's why I didn't have the option to use TJIs. So you know what? Let's stick to this. Let's go through it. So structural composite, we have a bunch of families. Peruse through it. Take a look at them. Google them. Read them. Understand them. You know, you guys know that these classes that we do here for design architects are for your own benefit, but you should have known these things before you started working. Isn't that pathetic that you're supposed to know this before you even start working at a place, but school doesn't teach it to you? That's ironic. So we're empowering each and every one of you to know more than most people that get out of school not knowing anything. So, but I would say, do your own homework. Look into each one of these members. Get a notepad, a little sketching notepad, and start sketching these things, understanding how they work. I will tell you right now that if you embed yourself into the process, into understanding these materials, you will eventually have fun doing this. It will be fun. It will be fun to understand how they make them, how they put them together, how they work. You will set yourself apart from the competition, from everybody else. And by the way, believe it or not, Felipe is the competition of Natalie, and Natalie is the competition of Felipe. This world is very competitive, guys. It's competitive. We're all competing against each other. Me and Marcos compete every month. It's not a joke. We take it seriously. I get mad when I lose. Really mad. And Marcos, he doesn't express it much, but I do. So that's it. It's a very competitive. So I want you guys to set yourself apart from everybody else by studying these members, understanding these members, okay? We'll model these guys on our Rhino model later. We'll talk more about each one of them. We'll understand how they work. But, know what they are, know what they mean. What do they stand for? ChatGPT is a powerful tool that you guys have. So use it. These books are a powerful tool that you guys have. Use them. Okay? So that's that. So that's it. Those are those members. We got through a whole lot of them. I'm almost done. So we'll talk, we'll talk about steel later and about tube steel later. We'll talk about those later. We'll stop right now at structural composite. I think this is a good place to stop. There's different brands, there's different types, there's different information about them. Look into them. There's YouTube videos about each one of these members, how they work, what they are. Sometimes the YouTube videos don't represent what you're looking for, sadly, but more often than not, they will. Okay, so that's it. I hope this is helpful. I hope this session is instrumental to your growth as flow design architects, and I hope it empowers you to grow, change the world, and teach it to other people. It's your duty to teach it to other people. Okay, thank you. Like, share, and subscribe, and we'll see you on the next one. Bye bye.